Hello, my name is Peter Jefferson, and my partner's name is Desmond Fung. Our team name is PID, and this is our final project for CS411. So our application is named PIP CS411 Academic World, and its scenario or use case is to provide information about universities and their faculty based on their research, location, ratings, and also to provide their contact information. Our target users are primarily for prospective and current students, but the application also has value for any others who have interest in universities and their faculty research, ratings, or location. The objectives of this application are to inform the users by finding faculty that relate to their specific interests, show the location of said faculty and the universities they belong to, provide the contact information of those professors, as well as a professor rating that is determined by the users of this application. It also allows an user to insert or delete any new or old universities to the database. So we used 3 databases in total for this application: MySQL, MongoDB, and Neo4j. We used MySQL for adding or deleting a university into the universities table. We also used MySQL for finding a professor's KRC value, which stands for Keyword Relevant Citation, which essentially just shows the user how many relevant publications a professor has had for a given keyword, say machine learning or data science. MySQL is also used for storing the location of a university by adding each university's address and coordinates to the university table. And lastly, we use MySQL for storing and updating a faculty member's community rating from 0 to 5. We use MongoDB for providing all the university names for a dropdown. And within that dropdown, we show the contact information for all of the professors for the selected university. For Neo4j, we show the university, professor, and number of publications of the professor for a given keyword, all within a specified time frame. To implement this application, we used a project structure recommended by the Dash-Platley framework. All of the design CSS files are in the assets directory. The data for all 3 databases are in the data directory, named by database. The database connection and query utilities for all 3 databases are in the db_utils directory. The source components directory contains files for each widget, as well as a layout.py file that controls the layout of the whole application. In the root directory, we have the standard app.py that holds the main function and runs the app. And the root directory also holds the readme file and the requirements.txt file. Our first widget is named Add or Delete to University Table. This widget allows users to remove old or add new universities to keep the data relevant and up to date. So to use this widget, the user must fill in all the fields that have an asterisk next to them. Otherwise, they will get a form validation error like this. So now I'll show the process of inserting and then deleting a university into the MySQL table. So first I'll open up MySQL Workbench and show that the university I'm about to add is not in the table. So I'll run this query. You can see it ran with 0 rows. So now I'll add University of Colorado Boulder. And then I have the radio button on insert and I'll hit submit. And you can see it says it successfully inserted the following into the university table and all the information I put in, as well as the university logo image. So now I'll go back to MySQL Workbench and run that same query. And you can see it is populated. So now I'll do the same thing, but I'll just hit the delete radio button. And so now it should delete the University of Colorado Boulder from the MySQL database. So I'll hit submit, and you can see it's successfully deleted. So now I'll go back to MySQL Workbench, run that same query, and get to see it no longer exists. This first widget uses 2 database techniques. The first is the use of a trigger, and the second is the use of a prepared statement. For the trigger, we have an action set up when the user clicks this submit button, and I'll show that in the code. So this HTML div is a form that I just showed on the website. At the bottom, there is a button here, and it has the parameter n_clicks that is instantiated to 0. So this button ID is an input in the callback decoration, and it eventually calls update_output. This function validates that the number of clicks is greater than 1, and then it does some basic form validation to ensure the user entered all of the required fields. And then it inserts or deletes the user provided information via prepared statements. So you can see for the insert, there is a prepared statement here for SQL. It is an insert statement. And then for the delete, there is a delete SQL prepared statement here. These prepared statements can help protect against security vulnerabilities such as SQL injections. In order to show university locations, we added some optional external data to our MySQL database to satisfy the external data sourcing extra credit capability. We added 3 columns to the university table here. You can see address, latitude, and longitude. We then populated the location data for each of the universities and created SQL insert statements for the rows. Our second widget helps users find professors' locations on a map based on the professor's published research on a given keyword. So this searches for the keywords in the database, and there is some form validation. So if I type in a keyword that doesn't exist and hit search, I'll get an error message back saying it does not exist and to search for another keyword. This widget can be helpful if a student is especially interested in, say, machine learning. They can search for that keyword and find all the professors who have published the most research on machine learning, as well as the universities they teach at and the location. So I'll type in machine learning, and you can see it finds that keyword and populates some data. In the bar chart, we have on the x-axis the universities. On the y-axis, we have the KRC, which is keyword relevance citation. And in the bar chart itself, we have the professor's name. If you hover over the bar, you can see the actual KRC value. In the bottom, there is a map that maps these 10 universities that were returned. And you can kind of see that in the northeast of the country, they have the most professors and universities with published research in machine learning. If I search for another keyword like big data, you can see that there are many professors at the same university, in this case UIUC, that have the most published research in big data. So this would be a really good university to attend for a student that is interested in specializing in big data. This widget also uses the database techniques trigger and prepared statements. Our third widget allows users to find all the faculty and their contact information for a selected university. So if I click this drop down, you can see it is populated by all of the universities in the university table. If I click one of the universities, you can see it populates every professor that belongs to this university. You can see that each professor has their picture, their name, their current position, their email, and their phone number if they were provided to the database. So extending off of our last widget's output, this can be helpful if a student would like to reach out to all the professors at UIUC that specialize in big data. So you can see there's quite a few professors here from UIUC. So I'll go back down and I'll select University of Illinois. And then I can scroll down and find those professors and their contact information and reach out to them. Widget 3 utilizes the database technique constraint to uniquely populate the universities in the widgets dropdown. In the code, you can see that I am getting all of the university names in this line to populate that dropdown. And if I jump to this function in the MongoDB utils file, you can see that within the MongoDB table, I'm hitting the faculty table, and I'm using the distinct argument to ensure that the already long list of universities does not contain duplicate values.
Thank you, Pete, for the great demo. Now, let's dive into the second half. Our fourth widget is designed to help users to find the top rated professors based on specific keywords. To support our widget, we added fabricated data, the rating column here, to mimic a faculty member's community rating from 0 to 5. To use this widget, we simply type in a keyword in the search bar. Let's do computer vision here and then click search. By default, the result is sorted in descending order. It will return a professor's name, its rating, which keyword they belong to, and the school they teach at. We can also filter the result by entering a professor's name here. Our fourth widget also supports form validation. So if a user type in a keyword that doesn't exist, for example, let's type in one here, hit search, it will return an error message. We also support multi-keyword search as long as they're commonly separated. Let's type in computer vision, comma, data mining, and then hit search. Now it is showing professors with keyword data mining and computer visions. To implement this, we added two input triggers to our fourth widget that will respond to our search button and the filter input. If the number of click is more than one and there is a keyword, we will call our MySQL helper method with the PIP statement here. After that, if a filter is provided, we will do some additional processings. Otherwise, we will use the result from the MySQL query to populate the professor's cards. Let's move on to our widget 5. Let's say you just took Professor's Change class and are very happy about the course quality. You wanted to give him a 5 out of 5 rating. What you can do here is click the drop down on the widget. The drop down will populate all the available professors in the dataset. Look up Professor Chang, click on it. This will update the data table with the existing data. Notice how the current rating is 4.05. What you can do now is pick a rating on the slider bar. Let's do 5 here because he's awesome. Hit submit. And you can see the rating just got updated from 4.05 to 4.53. Let's take a look at how we implemented widget 5. We have an update table method here that takes two input, the submit button and the professor's dropdown. When the user click on the submit button, it will trigger this method to update the professor's rating using our MySQL helper method here. Another way to trigger this is by selecting a professor from the drop-down menu. This will fetch the professor's data from the database and display it as a table. Our last widget, widget 6, offers users a convenient way to look up faculty research interests and their affiliations. Users can select one or more institutions from the drop-down menu, choose a year, select keywords related to their research interests. So let's do a quick demo here. For institute, let's pick CMU as well as UIUC. Let's stick with the default year 1970 and select keyword. Let's do computer vision as well as machine learning. Click search. This will generate an interactive table displaying the faculty name, their institutions, and their publication count since the selected year with the specified keyword. This table is fully interactive. You can sort it by publication count in either direction or filter it to only show faculty member with more than 100 publications. What makes this dashboard so great is, let's say you are Alex, an undergraduate student who's passionate about computer vision and is looking for the best master's program. Alex start by using our second widget to identify leading schools in computer vision by entering computer vision and hit search on our second widget. Alex sees that MIT is one of the schools that stands out. And looking at the map, looks like most schools with high publication scores are centered around the East Coast. That's interesting. To verify this idea, Alex turned to our fourth widget. Upon searching computer visions, Alex discovered that Professor Taraba from MIT has a high rating and is renowned in the field. This confirmation strengthens Alex's interest in MIT. Finally, Alex uses the last widget to dive deeper into Professor Taraba's credential. Let's type in MIT here, select keyword, computer vision, hit search. By checking the publication count, Alex finds that he's ranked second in MIT's, indicating a significant impact in his area of expertise. Impressed by his findings, Alex decided that applying to MIT's program and seeking mentorship from Professor Tarablas would be a great choice.